Hello, this is Monday's lesson. We're in chapter 6.4 now. We're doing objective 1 today, which is mostly upstream, downstream type problems. And we've done these in the past, but we tried to make just one equation. Now we're going to do it with two equations and two variables. And I'm going to try to stick to this format for all of these. We'll use R for the rate of the vehicle, car, boat, whatever it is, for the rate or speed in still water or still air. And the W will be the speed of the wind or the speed of the water or whatever is, either pushing back or helping the vehicle to move. So this ought to look somewhat familiar when we want to do the speed with the wind. We add the speed of the wind to the speed in still air or still water. No, this is the speed with. I could just use the word current. That would apply to wind current or water current. So R plus W for with the current, and you probably figured this out already in a split second. R minus W would be the speed against the wind or against the current. Okay, and then the other real important idea here is that the speed times time equals the distance, or rate times time equals distance. So here we go. We've got a plane that flying into the jet stream, that would be against the wind, flew 1,750 miles in 5 hours. So if I write that out, 5 for the time, and then it's against the wind, so R minus W for the speed equals the distance, 1,750. It goes on to say, when it flew with the jet stream, with the wind helping it, it covered 2,250 miles in the same amount of time. So same amount of time means we use the 5 hours again, and we say 5 hours times speed R plus W for the rate in still air plus the wind speed made the distance this much, 2,250. Here's a nice thing about to happen with just about all of these. We could use the distributive property and remove the parentheses here, but almost every single one of these is going to be true that whatever this number is over here, the distance is going to be divisible by the time. And so if we just divide both sides of this by 5, divide this side by 5, you get the R minus W. And then on the other side, 1750 divided by 5 is 350. I have one equation that says R minus W is 350. Same idea here, divide both sides by 5. Let me write that up here. Divide by 5. Divide by 5. We're going to have R plus W equals 2,250 divided by 5, 450. Okay. Now, if you need a moment at any time in any of these videos, push pause for a minute, hit rewind, give yourself a chance to catch up, think, ask questions. Notice that after this division step, we don't have to do any multiplying to get opposites. We've got opposites right here, minus W and plus W. We're ready to add the columns. Be careful though, remember that R plus R is really 1R plus 1R makes 2R. 2R equals 350 added to 450, that's 800. And then if we just divide both sides by 2, you get R equals 400. Well, what's that represent? That's the speed of the plane in still air. So we could say plane 400 miles per hour. Plane goes 400 miles per hour. And then use that 400 for R. You could use it here, 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 or here. Where's the easiest place to use it? I'd say this last equation is the easiest place to use it. Probably don't even have to write this out, but I will anyhow. 400, R was 400, so 400 plus W equals 450. Subtract 400 from each side, and you've got the wind speed was 50 miles per hour. So the plane was 400, the wind 50 miles per hour. Okay, let me do number 2. Number 2 says a canoeist paddled 14 miles in 2 hours when going with the current. So with the current, that's the rate in still water plus the speed of the current. How much time? 2 hours. 2 hours times with the current speed, they went 14 miles. Goes on to say over here, it also took 2 hours to go 10 miles against the current. So here's against the current speed, 2 hours time, only 10 miles. Now I'll proceed as in number 1. I'll divide both sides by 2. I'm dividing by 2, and that gets rid of the parentheses. And 14 divided by 2 is 7. And take this one and divide by 2. That gets rid of those parentheses. And 10 divided by 2 is 5. And look, again, we got opposite coefficients, 1W and minus 1W. This is ready to add. 1R plus 1R is 2R. The W's cancel. 7 plus 5 is 12. Divide both sides by 2. We get R equals 6. So the canoeist was paddling 6 miles per hour if there was no current. That's for the canoe. And what was the speed of the water? Well, if we put a 6 in here, 6 plus W equals 7. If I say 6 plus W equals 7, I'm going to take away 6 from both sides, and we get 1 mile per hour for the current. Okie doke. And number 3. There's the mile, there's the distance, the mileage, there's the time. And what about the speed? Flying into a headwind means against the wind. That means I'm going to write 3 hours times speed R minus W was 270. Second part of the story, flying with the wind helping, and 2 hours time, the distance was 260 miles. See, less distance, but also less time. Remember, this is faster. This is with the wind is faster, against the wind is slower. So, divide both sides of this by 3 to get rid of the parentheses, and we're going to have R minus W equals 270 divided by 3 is 90. And the second equation, we're going to divide by 2. Since there's a 2 out there, divide both sides by 2. We get R plus W. 260 divided by 2 is 130. Now we're ready to add the columns. 1R plus 1R is 2R. Minus W plus 1W. W's cancel. 130 and 90 is 220. Divide by 2. Get R. 110. So the plane, 110 miles per hour. And then what about the wind? Well, we can take Again, this last equation looks to me to be the easiest one to plug that number in. Instead of R plus W, I'm going to write 110 plus W. 110 plus W equals 130. And then take away 110 from each side, and we get W equals 20. W equals 20, so the wind, 20 miles per hour. Okay, so that's 10 minutes on page 1. I'm going to stop the video now, come back for part 2 for page 2.